So today's lesson represents the final nomenclature or chemical naming lesson this year in grade 10 science. So I want to kind of just revisit where we're coming from and also see where we're going. Here's my flow chart. So here's where we are so far. So we've learned so far about compounds that are binary, containing only two elements, and we know that those binary compounds can either be made of, when we examine the types of elements they're composed of, they can be composed of two nonmetals, like we just saw, or they can be composed of a metal and a nonmetal, in which case we need to see, well, is that metal monovalent or is that metal multivalent, right? So, and the rules are there, and it depends on what we're looking at. But what we haven't visited, and many compounds, ionic compounds, contain more than two elements, and three or more, and so we call those ternary compounds. And so what the last piece is this year that we're going to look at are the ternary compounds. And so this is going to be incredibly important for you to understand the process of, because it has a huge bearing on us predicting the products of chemical reactions, which will be part of the final course pieces that make up grade 10 science. So here we are. So these are the ternary or tertiary ionic compounds. Okay, so remember that they're ionic, and so the same rules of reducing to lowest terms are going to apply to this, and we'll see that in our examples. Okay, so these compounds, as I mentioned, have three or more different types of atoms, and so they usually often will have what we call a polyatomic ion. And that is like a new idea for us. So let's, slow down and talk about that. Poly is a prefix that means many in science. So polyatomic means many atoms. Okay, polyatomic. And then ion means charged. So really, what a polyatomic ion is just a charged particle made up of multiple different atoms. So here's an example of that. So in this formula, I see CaSO4. Well, this SO4 bit is an ion that is made up of more than one atom. It is called a polyatomic ion. Okay, and we're going to look at a bunch of them. Now this year you're going to be provided with this chart when and if you need it in order to help you name compounds. I can tell you that in grade 11 you will need to memorize all of these and a bunch of other ones. So this year not so much. So take advantage of that. I think the process is pretty straightforward if you understand the crossover rule. Which is why, at the beginning of this unit, we emphasized you making sure at every stage that you had a solid understanding. So at this point, this really should not be a huge jump for you, because what I'm about to show you, you will have to refer to on your tests and quizzes, as long as you understand the crossover rule. Okay, so ammonium. So hopefully you have this table in front of you from those printed off skeleton student notes. So ammonium has the formula. Oops. Sorry about that, folks. Had to switch to my handy Jamboard so that I can write down some of these chemical formulas. So ammonium has the formula NH4+. So notice again, it is polyatomic because it's this whole thing, not just the H, not just the N. The whole thing has an overall charge of +1. And so when I write just plus, that also means +1. Okay, and we're going to, don't fret, I'm going to show you how to use these to get the formulas for compounds. Hydroxide, so you may have heard of sodium hydroxide, which is basically Drano. And it has the formula OH with a -1 charge overall. So again, if it's -1, we can simply write negative. Carbonate. So carbonate has the formula CO3. And this whole polyatomic ion has the charge -2 or 2 negative. So I often get asked, does it matter whether I put the negative in front of the 2 or behind? No, you'll see both, and both are fine. Okay, next. Chlorate. Chlorate is ClO3. With a -1 charge. And you'll notice a lot of these have an 8 ending. So if I were to say chlorate versus chloride, well, chloride would just be Cl, but chlorate, that 8 ending tells me that it's this polyatomic ion. Okay, but you'll have this chart this year. Next, we have nitrate. So the 8 ending is telling me it's not just nitrogen. It is this polyatomic ion with the formula NO3 with a -1. Okay, moving on. So next I have sulfate. And so sulfate rather than sulfide, the 8 ending is telling me that I have a polyatomic ion, SO4, with a 2 negative charge. Now, hydrogen carbonate or bicarbonate, those are mean the same thing. Maybe you've heard of sodium bicarbonate. That's actually just baking soda. And so hydrogen carbonate or bicarbonate has the formula HCO3 with a -1 charge. Okay, so notice that carbonate and bicarbonate look a lot the same, and that prefix bi, or the hydrogen, you can see how that sort of fits in there. So maybe you have a guess as to what hydrogen sulfate might be. So hydrogen sulfate has the formula HSO4 with a -1 charge. Okay, next we have the 2 final ones. We're almost there. Acetate has the formula. This is a bit wonky, folks. But remember, again, you'll have the chart. C2H3O2. And this whole big thing has overall a -1 charge. Okay, now I want to differentiate for you between the subscripts, which are below, that tell us how many of each atom we have, and the charges. And these charges tell us, well, the charge, and that's what we're going to use in our crossover rule. But these little values down here, these subscripts, remember to put them down below and not above as exponents, because if they're above, then that refers to their charge and not the number of atoms. So that's just a bit of a housekeeping issue. Okay, last I have phosphate. So phosphate is PO4, oopsies, 4, with a 3 negative charge. Okay, that's phosphate. So now that we have our polyatomic ion chart filled in, I want you to, maybe what a good idea would be to take a photo of this chart if you don't have it written down somewhere, but you really do need to have this handy for what we're about to do next. All right, so let's practice naming some of these. Again, hopefully you have that chart right in front of you to reference so that you can see where I'm pulling things from. So the same rules that we use for ionic compounds, any metal, non-metal compounds, we're going to use here. So we're going to reduce to lowest terms. Magnesium hydroxide, for instance, we have, we're going to put brackets around our polyatomic ion and then cross over the charges. Okay, so magnesium is a metal, hydroxide is a polyatomic ion, so that makes this ionic. Okay, we're going to put brackets around our polyatomic ion and then cross over the charges. So magnesium has a charge of Mg2+, and I find that on the periodic table. And hydroxide has the formula OH- with a -1 charge. So this is the way that we want to go about this, folks. What we want to do is whenever we see the polyatomic ion, we want to put brackets around it. And then what we do is we simply cross down those charges as we have been doing in previous questions. So since this is a 2, that 2 is going to go down, but outside the brackets, outside of our polyatomic ion, so that 2 applies to the whole shebang, the whole thing. This negative really means a -1, right? So that 1 is going to get crossed down there. And so what do we end up with as a result? Mg bracket OH bracket 2. And remember, if it's a 1, we could put the 1 there. Typically we don't, but that 2 right here is just getting crossed down and outside the brackets. Okay, so the process is the same as what we would use for any ionic compound, except that we're going to put brackets around our polyatomic ion. Okay, so what I have now is my trusty Jamboard, and so we're going to go through a few examples to show you exactly how to go about using this chart right here when we're creating the formulas for our tertiary or ternary compounds. So let's go through a few practice problems. So I'm going to go through the first one, and then I'm going to leave you loose to try the next few ones on your own, and hopefully you'll engage in thinking about these problems, because that is how you're going to get the most out of this learning opportunity. So calcium nitrate. So calcium, I'm going to refer to my periodic table, and I'm going to see that calcium has a 2+ charge, always. Okay, and notice no Roman numerals here because calcium is a monovalent metal. And now I see with nitrate that it has that 8 ending there, which is telling me this is not simply nitrogen. It's going to be this nitrate over here. And again, you will have this chart when writing your quizzes, and so that will make life, I think, a little bit easier for you this year. So let's go ahead. So NO3 with a -1 charge. So the way that I typically teach this to students is I say, whenever you see that polyatomic ion, that charge that's out there applies to the whole thing. So it's sort of like in math. If you had a math problem, let's say for instance, and you had this like 2 outside the bracket, and then you have brackets, you know that that 2 applies to the whole thing inside. So same idea when we're working here. So I want to put brackets around my polyatomic ion before crossing over my charges. Now remember, when I have negative there, that assumes a -1. So now the last step that I need to do is simply take the charges that are up here and cross them down, but I'm going to cross it down and outside that bracket. Okay, take this one, cross it down right beside and below the calcium. And so what does that give me for my formula? Well, that's going to give me Ca, and then I'm going to keep that bracket, NO3 bracket, and then this 2 right here is going to be out here. Okay, so remember the 1 right there, I can put it in. Usually you won't put it in grade 11. I'd be looking for you to not put it in. This year we're going to be a little lax on that. Okay, so what I'd like you to do based on what I just showed you is to go ahead and try to do the same thing for this second example, copper 2 sulfate. So pause the video, give that a try, and then resume the video when you're ready to take it up. Okay, so let's take a look at this question. So first of all, I see that these Roman numerals, that Roman numeral is there, and that is indicating that copper is a multivalent metal, and that the charge on the copper ion is +1. And so I'm going to go ahead and just write that out. So Cu +1. And so I'm seeing here also that sulfate has that 8 ending, and so it's telling me it's not simply sulfur on my periodic table. I'm going to be looking for my sulfate polyatomic ion from my chart. So I'm going to go ahead and write that out. It's SO4 with a 2- charge. And so now I'm going to do what I did before, which is to put brackets around my polyatomic ion, and then go ahead and cross down those charges. Okay, and what I get when I do that is I end up with Cu, and then this 2 over here comes down, and then I have bracket SO4 bracket 1. Now, here's where I'm going to take a little pause. I'm going to say to you, let's say, for instance, in a math problem, okay, this is over on the side, I'm just kind of thinking, I had a 1 outside that bracket, right? Well, if all it is that I'm multiplying into whatever's inside the bracket is I'm multiplying by 1, that's not going to change anything inside that bracket. And so really, I don't really need that 1 out there. And that means that I don't really need to have those brackets there, because 1 times anything just gives me the same value as I started with. So what I would normally want to do is I would normally want to take that and write it as Cu, pardon me, Cu to SO4 without the brackets. Now, for this year, if you include the brackets because it helps you, that's fine. But typically in grade 11, we would not want to show that. Okay, hopefully you did okay with that. If not, I'm hoping that you're doing this early enough so that you can reach out and ask for some help via Zoom. Okay, so here are a couple more problems. So I would like you to pause the video and try question C right here. Try C on your own, and then when you're done, resume the video and we will take it up. Okay, so I'm going to go through this question. So magnesium is a monovalent metal with a charge of +2 always. Carbonate is on my trusty little chart right here, carbonate. And so I simply write out that polyatomic ion, CO3 with a 2 negative charge. Now I'm going to put brackets around my polyatomic ion to show that this -2 over here applies to the whole thing. And also when I look at the charge on the cation, I cross it down and that charge applies to the whole polyatomic ion. Okay, so now I'm going to do that. So you have this 2 that's going to go down there and this 2 that's going to go down here. And let's take a look at what we get. So what I get is Mg2CO3 bracket 2. Now if you got there, that's pretty darn good. But I want to remind you that this is still an ionic compound, right? And if I have 2 magnesiums for every 2 carbonates, that is something that I would want to reduce to lowest terms. So in fact, I would want to just simply, 2-to-2 ratio is the same as a 1-to-1 ratio. So I would simply just kind of get rid of that. And now that I've gotten rid of the 2's or the values outside those the brackets, I really don't even need the brackets. Okay, so let's bring those 2 pieces together. And this formula would be MgCO3, magnesium carbonate. Okay, so next is ammonium phosphate. So pause the video and then give that a try. And when you're ready, you can resume the video and we will take it up. Okay, ammonium phosphate. So ammonium has the formula NH4 with a +1 charge. And phosphate is PO4 with a 3 negative charge. And so where did I get that from? Well, here's ammonium, and then here's phosphate. So now, in this case, this is a different example, right? So I'm hoping that you tried it out, and you'll see from this whether you got it right or not, and if you got it wrong, at least trying it, you'll kind of make better sense of what it is that maybe you made a misstep on. So I'm going to put these brackets around my polyatomic ions. Okay, this compound is made up of 2 polyatomic ions, but the process is the same. We're going to put brackets around both of them, and then we're going to cross these charges. Remember, this is +1. We're going to take that and cross it down. We're going to take this 3 and then cross that down. And so what do we get as a result? Well, we get NH4 bracket 3. Remember this 3 over here. And then bracket PO4 bracket 1. And since this 1 right out here, is outside the bracket, multiplying that into the bracket's not going to change it. And so I actually can just drop the bracket. And so my final formula, and in the proper way, would be NH4 bracket 3 and then PO4. Okay, so hopefully, we're getting into some heavier territory here. So if you are struggling, don't be shy about reaching out. I'm more than happy to do some more practice problems with you. Okay, so, and this is the more important skill, because in grade 11 chemistry, which is really just a math course that we apply and we solve problems with, getting those formulas correctly is going to be a big deal. So that's a skill that you're going to want to master. Maybe not this year, but this year will get you started certainly on that. Okay, so here's the reverse situation where I'm asking you to take the formula and write it in, in English words using our alphabet. This would be, something you would do if you were writing up a lab report, for instance, and you needed to use the full name, which is what you would do in sort of a paragraph. So what I'd like you to do is I'd like you to try, well, you know what, I'm going to do the first one with you, and then the next two you can try on your own. Okay, so I can see here that lithium and acetate are together. And where am I getting this bit about acetate? Well, remember, acetate is just on my chart, right? Where is it? Let me find. Here it is. There's acetate, right? And so acetate with lithium, that is an ionic compound. So I need to see, well, is lithium a monovalent metal or a multivalent metal? And because it's in group 1, it is a monovalent metal, and so I do not need to use Roman numerals, and in fact, if I do, that would be wrong. So straight up, the word name for this would be lithium acetate. And that's it. Okay, so here's what I want you to do. I want you to try B out. And so pause the video, give B a try, and then we will come back to it in a second. Okay, so hopefully you engaged in trying to think about this. So when I look at calcium, when I look up calcium on the periodic table, I can see that calcium is a monovalent metal, which means I am not going to be using any Roman numerals or Latin suffixes at all, okay, Latin endings. So, all right, so here we go. Calcium is just straight up C calcium. And then this PO4 business, well, I recognize the polyatomic ion, and so I'm going to go ahead and I'm going to find it on my chart, and here it is. It's PO4 with a 3- is phosphate, and so that all I need to do now is just write that in, phosphate. And I'm done. Hopefully you did okay with that. So give the third one a try, pause the video, and resume when you are ready. Okay, so I'm going to give this a try. When I look at this question, I first am looking to see, well, what is it composed of? Well, I have a metal and a non-metal, so it is ionic. But the metal that I have here is iron, and iron has two possible charges, right? Iron is multivalent. And so that means that I'm going to have to put either some Roman numerals in there, or I'm going to have to use those Latin names with the different endings. Okay? And here's where, I may want to use a test cross or a reverse crossover rule. Okay, to tell that the charge on iron is what the charge on iron is going to be. So I'm going to start with this carbonate here. Now, carbonate has a charge of 2-. And so I'm not seeing that there are any numbers out here, right? So the only charge that's possible for iron in this compound is 2+, right? Because this 2 right here would have to have been reduced because of that 2 right there, okay? So the cation to anion ratio is 1:1, which means I'm not going to have any subscripts, right? So why does that help me, and why does that matter right now? Well, it matters because I have to somehow include in the name iron carbonate, that little 2 there, to let the reader know that it's the iron ion with the 2+ charge and not the 3+ charge, right? So this should be iron 2 carbonate. Or if you listen to the Latin lesson, it would be the lower of the 2 charges for iron. So this would be ferrous carbonate. And that is it. So this is the last lesson for this week. I'm going to give you some time. Obviously, next week you have some time and next weekend to work through some of these nomenclature ideas. And we'll finish off on Monday with nomenclature, with a quiz on all of nomenclature. So make sure that you take some time to invest in really learning these rules. And again, next week, feel free to reach out. I'll be happy to help you next week as well if you need some extra help.